Aloha class, we're on 7.7, parametrics and vector calculus. Let's get into parametric arc length. Okay, we got our blue going. If you remember, if we are in rectangular coordinates, my little formula is the fancy antsy L is equal to the integral from A to B, the square root of 1 plus the derivative of my function, and then remember we square that bad boy dx. If we're dealing with parametrics, since I have an x component and a y component related to t, this is our arc length formula, okay? So example 7, without a calculator, find the arc length of the given curve if x equals t squared, y equals 4t cubed minus 1 from 0 to 1. So easy peasy, chop-on easy. Sup, finals are done. Papa Holmes. What you getting me for Christmas, Papa Holmes? All right. Let's go ahead and do this bad boy, okay? So we got arc length, little fancy L, is equal to the integral from 0 to 1, the square root of, okay, dx dt, which would be the derivative of that boy, which would just be 2t, and we're going to square that bad boy, plus dy dt, which would be 12t squared, and we're going to square that dt. Now it says to do this guy without a calculator. So we go from 0 to 1 of, let's go ahead and simplify. I get a little 4t squared plus a little 144 t to the 4th dt. Now, I don't know about you, but that kind of looks undoable. But however, it actually kind of looks factorable. So even though I can't find the antiderivative of that yet, maybe I will go from 0 to 1, and maybe I'll factor out a 4t squared. If I factor out a 4t squared, I get a 1 plus 144 divided by 4, I think that's, 36t squared dt. Now, that still kind of doesn't look factorable. However, this guy here is 4t squared times a quantity. So I could actually take the square root of that bad boy, and when I do that, I bring out a 2t, and then I end up with the square root of a 1 plus 36t squared dt. Now, if you're like me, you're like, oh, sweetie pie. That definitely looks like U-sub could get some stuff done for us. Now, remember, some of us use U-sub. Some of us are getting better at not using U-sub. What do we want to do here? Let's try to do it without a little U-sub, okay? If I try to do this without a little U-sub, my U would be that right there, right, class? And the derivative of that would be a 72t. And the t's would cancel themselves out, right? So I would end up with a 2 over 72, right, class? And I know that because if I did use sub, I would have to divide that 72 out there, okay? And I'm gonna go ahead and keep that as my outside, right? 2 over 72. I can pull that guy out. And then what I'm going to have is I'm just going to have to take the antiderivative, and this would be to the 1/2 power. So the antiderivative of that would be add 1 to that guy. And if I added 1 to that guy, it would be, right, I already took care of the inside, right, class? But if I added 1 to that, it'd be a little 3/2. But then I have I have to divide by 3/2, right? Which means I multiply by the reciprocal, and I get a little 2/3 right there. Make sense, class? And then I'm going to evaluate that from 0 to 1. How about that? I was able to do all of that without a calculator. Now, if I simplify that correctly, I think I have in my notes here, we get a little 1 over 54. Okay, 1 over 54, I'm going to factor that out. And then I'm going to go ahead and plug in a 1. And if I plug in a 1, I get a 37 to the 3/2. And if I plug in a 0, I just get a 1. All right, and there you go. How about that? Was able to do that all without the use of a calculator. Now, this video is going to be shorter. I kind of got disrupted at the end of the last one. You know, it's finals time. I had to get ready for a final. But believe it or not, you're in charge of the rest. So I hope over break you're going to have a lot of time to look at this, and I challenge you to see how you can do with it, okay? What I want you to do is really read over these notes on horizontal and vertical velocity component vectors. And it's stuff we've done all year. It's just that when we talk about position, okay, when we talk about position, okay, and that's a little S with like a fancy bar. It just means it's a vector. Velocity with a fancy bar, okay, and A with a fancy bar, okay, we always write those as vectors. And they always have an X and a Y component. And all it is position's just X and Y. Velocity is just the derivative of x with respect to t, the derivative of y with respect to t. And acceleration is the second derivative with respect to t, and the second derivative with respect to t in terms of the x's. Okay, get off your screen. So let's go ahead and look at this stuff. Second derivative, right? We all know how to do that now. We have what we call the norm or the magnitude. Okay, we have the norm or the magnitude. And if I do the norm or the magnitude, it's just the arc length. Okay, not the arc length, I'm sorry. It doesn't have that integral from A to B. Let's get rid of some of this stuff, right? Who would want a Tesla, right? We have a speed of a magnitude, length, all of that stuff means that formula right there. If we talk about arc length, we just went over it, means that bad boy right there. Remember that from previous stuff, that all means total distance. So what your job to do over break is to work hard and get good at this, okay? We're going to save the worksheet for the first day back so we have something to do. But what I would like you to do after watching these couple of videos is do example 8, 9, and that's it. That's it. That's all you got to do. So watch a video. I think it's about 25 minutes in length. Do those right there and be ready to go come Monday. Aloha. Mele kaliki makaha. And have a happy new year. Aloha.